Chapter 7. And we are going to introduce a word here you've probably heard before. And the word is ratio. What do you think of when you think of a ratio? Fraction, very good. Okay, when I think of a ratio, I think of a fraction. Okay, or it's a comparison between two numbers. Somebody said like 3/5. Yeah, that's a fraction and that's a ratio. We're comparing 3 to 5. It's 3 out of 5 things, if you want to think of it like that, okay? So let's say you had, I don't know, a box of candy and you had 5 pieces of candy in that box and you're going to take 3. You take 3 out of 5. You take 3 from 5, right? Follow me on that? So, yeah, it's a fraction. Another way you could write it would be like this. You've probably seen this before, haven't you? With a colon, 2 dots right here. And we could say that's 3 to 5. So this, we would say 3 to 5, TO. And then this also, you could say the same exact thing. Right? Most of the time we're going to write them as fractions. But there are times where they do write it with a colon right here, okay? And every once in a while you'll see it like that. So you need to be able to see both things. All right, pretty simple, right? That's that. Let me see what I did next. All right, let's go to this next. Let's talk about TVs. Look at that right there. Pretend that's a TV, widescreen TV. All right, if I said that that was 32 inches straight across the top and up and down, the height of it was 18 inches, and I asked you to, or I wanted to find the ratio of this television, okay? This is a number that actually shows up quite a bit, especially when you do work with like high definition stuff. This number is very, very prevalent, okay? You see it all the time. Not these two numbers, but watch what we're going to do. Let's compare. Let's compare, we'll call this the width and the height, okay? So this is the width of the television, and this is the height of the television. If I wanted to make a comparison, and I wanted to compare the width to the height, watch, width to the height. Comparison is a ratio, it's a fraction, so I put W over H. What is the width of this television? 32. And what's the height of this television? It's 18. Okay, now watch. When we write it as a fraction or a ratio, we don't just leave it like this. We're not going to change it into in a decimal. There are some times where you do change things into decimal, and probably the next example that I do, we will change it to decimal. But for the most part, we're going to keep it as a fraction. But what should you always do with your fractions? You should always reduce them. So what goes into both of these things? What goes into 32 and into 18? 2. 2 goes into 32 how many times? 16. 2 goes into 18 9 times. So it's 16 over 9. Or we say this TV is in the ratio of 16 to 9. Has anybody seen that anywhere? I see it a lot because I deal with photography, I deal with video, and video, high definition video, the format for a high definition video is 16 to 9. You see that all the time when you're in that world, okay? Some of you guys, all you do is just watch TV and that's it. You have no idea what the sizes are or anything else. But when you talk about a widescreen TV, you say it's in the 16 by 9 format or 16 to 9 format. What about that TV up there hanging in the corner? Is that a widescreen TV? No, it's not a widescreen TV. It's no, it's not a square either, is it? It's not a perfect square. Are the old TVs perfect squares? No, they're a little bit rectangular, aren't they? About like that. They're a little bit rectangular, but not, you know, not as rectangular. I don't know if you want to say that, but it doesn't go as wide, of course, as a wide screen. That's why they call it a wide screen. Any idea what the format on a standard instead of 16 by 9? Now, let me go back to this. Does this mean every widescreen TV is like 16 inches wide and 9 inches tall? No, that means for every what? 16 inches this way, it's going to go what? 9 inches this way. You with me on that? Because if we went 16 and 9, then another 16 and another 9, then you get the whole TV, wouldn't you? All right. Nobody knows what the format is on a regular standard TV? Josh, you with me? Okay. Shake a little bit. Shake your head. All right. Did you get sleep out of you yet? That wasn't a very vigorous shake. Come on. If I'm tired, go like this and just kind of shakes it out. There you go. All right. So look. On a regular standard TV, it's 4:3. Nobody's heard of that? 4:3. Look around. If you go to an electronics store or something like that, you may see that 16:9 or 4:3, or if you do any research. But if you're not dealing with that stuff on a normal basis, you probably wouldn't recognize those. But those are really important numbers right there. When I deal with video, they talk about 16:9 all the time. And they talk about 4:3. Thank you. All right. So those are ratios. I'm just a real world example to just talk about ratios. And by the way, just for fun, if you go out and buy a television, like you probably know some of the numbers. Like my television, I think is like a 42-inch TV, but now the TVs are even bigger than that. I thought I was getting a giant TV when I first got mine, but now you can go and you get like a 50-inch high def TV, right? You ever hear that? People talk about that. Oh, I'll get a 50-inch, or I'm going to get a 80-inch TV. What are they measuring when they throw those numbers out? Are they measuring out how wide it is? Are they? No, it's inches. It's a length that you can actually measure on the TV. The inside? What do you mean the inside? Come on, we just had a whole chapter on this. What do you think? It's not the width, and it's not the height. So what do you think that... Is it the angle? Can't be the angle, because that's 90 degrees, right? The interior what? Come on, give me a good geometry word. We've talked about this word dozens and dozens of times in the last chapter. It's not this part of the rectangle. It's not this part of the rectangle. What other thing could you possibly measure on this? Give me one word. I want one word. Nope. Because the mid segment would go from here to here. It'd be the same length as the 32, wouldn't it? The diagonal. Yes. The diagonal. Does that not occur to you at all? No? I mean, that's the only other thing that we've talked about in that other chapter, isn't it? Okay, we talked about this, parallel sides and these parallel sides. What else? We've talked about diagonals dozens and dozens of times, haven't we? Right. Right. Make it square. Yeah. Yeah, exactly. But we've talked about the diagonal, right? Yes? Are you guys here? You guys are killing me, man. You're a tough audience, man. You are a very difficult audience. So, makes it hard for me. Like a little bit of feedback here. So look, from here to here is what they measure when you find the size of a television. So if you go and they say, here, look at our 50-inch television. And then you can take out your little ruler, right? That you always carry around with you, right? Maybe not. I don't either. So I'm not that bad, okay? I'm not that geeky. I'm geeky, but not that geeky. All right, but if you wanted to, you could actually measure from here to here, and that's what the length of the television is. So if they say 50-inch TV, that's what it would be right there. Make sense? All right. Let's go on to something else. Let's go to baseball. Anybody like baseball? You don't like baseball? How can you not like baseball? What are you, communist or something? You're from Russia? Oh, you got the injuries from it, so you have bad memories of baseball. Let's talk about this. Another ratio is the batting average. Batting average is a ratio. Anybody know how to find the batting average? It is a decimal, you're right. But a decimal is a fraction, though, isn't it? So we're going to write it as a fraction. How do you find the batting average for softball or baseball? How do you figure it out? They always throw it out there, right? Somebody comes up, Chase Utley up to bat. He's hitting 275. What does that mean? What does 275 mean? He has at some point. Well, not lately. He's injured now. He's not even going to start the season. Anyway, somebody gets up there and they say we're hitting 275. What does it mean when they're hitting 275? It's the number of what?
Hits.
It's hits, right. It's the number of hits that you get divided by what? The number of outs? At-bats. That's right. Thank you. It's the number of at-bats. Okay, so it's the number of hits you get divided by the number of at-bats. So Shannon, you came right at the right time. That's how we figure out batting average. All right, she's a softball player, so she knows all about this stuff, right? Okay, so it's the number of hits you get divided by the number of at-bats. Here's kind of an interesting thing, is the number of at-bats. It's not just the number of times you actually walk up to the plate, right? Like if you get a walk, is that considered an at-bat?
No.
No, it's not. Okay, so if you get a walk, now you didn't get out, so it doesn't count against you, but it doesn't count for you either. It's like you never even showed up, all right, when you get. Now, on base percentage is a different thing. Anybody hear that? Okay, got a lot more girls than guys in here, so maybe the girls don't care so much. But Shannon, you know about on base percentage, right? On base percentage is doesn't matter how you got on base. Okay, it could be a walk. I think errors are included on base percentage. I think even if you get on by an error, somebody bobbles the ball and you should have been out and you still get on base, I think that still counts as on base percentage. But that's a higher number than what the number of hits are. Okay, if you hit the ball and somebody should have caught it but they missed it and it's an error, that counts as you being up to bat, but it counts as you getting out, even though technically you weren't out. Did you know that? Okay, so that's what happens with if you get on by an error. But let's say, we'll make this real easy. We'll just make the division real easy. Let's say you went up to bat at 100 times. Okay, so you had 100 legitimate times at bat. And let's say you got like 30 hits. Okay, so you got 30 hits and you went up 100 times. Now look, out of 100 times, you got 30 hits, which doesn't seem that great, does it? Out of 100? What if you got that on a test? What if you got 30 out of 100 on a test? Would that be good? That'd be terrible, wouldn't it? I mean, you'd be big trouble. You'd be in the basement, whatever, Your grade would be terrible. It would be horrible. But if you're a baseball player, a professional baseball player, and you got 30 hits for every 100 times you got up to bat, you're doing pretty well. You probably make the all-star team. Did you know that? That's kind of interesting, isn't it? Yeah? Okay. So what if you put this in a calculator, 30 over 100? The reason I used 100 because we can do this in our head, can't we? So the decimal's here, move it 2 places. What would it be? It'd be 0.30. Now, batting averages, they always take 3 decimal places, okay? So what are you batting? If you go up to bat and you hear the announcer on TV, okay, Jonathan Haney comes to bat, and he's batting what? Do they say .300? No, he's batting what? 300, right. They say he's batting 300. What does that mean he's batting 300? That means for every 100 times at bat, he gets 30 hits. Or every 10 times at bat, he gets what? 3 hits. You follow me on that? It's the same average, or it's the same ratio, isn't it? Okay? It doesn't seem that good, does it? But that's how hard it is to get a hit in baseball. If you get 3 hits out of every 10 times going up to bat, you're probably making the all-star team. You're doing real good, okay? And that's crazy. What other thing in life can you fail 70% of the time and be considered very, very good at it? It's probably not a whole lot of things. Golf, maybe? I don't know. I think baseball would be even harder than that because the guy's throwing the ball at you you're at close to 100. I was going to say 300. At close to 100 miles an hour. At least the ball's just sitting there, right? And everybody's all quiet and everybody whispers. They should make golf. Golf would be much more exciting if you had the crowd all around, like yelling and screaming and stuff when they hit the ball. Wouldn't that be more interesting? Or it's against the etiquette, so they don't do it because it's not etiquette. But in baseball, everybody's in the stadium, right? You have like 40, 50,000 fans in the stadium yelling and screaming and cussing, and I don't cuss at them, but some people do. Go to Philadelphia, you hear a lot of that. But they're all screaming and yelling, and the guy's throwing the ball at you almost 100 miles an hour, and plus the ball's curving, and it's dipping, and it's doing all kinds of crazy things, right? And they still are expected to hit the ball, right? But in golf, you can't do that. You got to whisper, and everybody's all quiet, and everybody's all polite. And even if you hit a bad shot, everybody politely claps, golf clap, right? But in Philadelphia, see, that's what I want to see. I want to see him play golf in Philadelphia when you get real Philadelphia fans there and people are yelling and screaming at you. And I want to see how well they can hit the golf ball then.
Right. Do like some crazy hole with some club in there.
Is that right? So I would be I'd watch golf if they started doing that kind of stuff. That'd be kind of fun. Anyway, so that's what batting average is. All right. So batting average, we actually use the decimal. But normally, when we do ratios, when we talk about ratios in here, we're going to use the fraction part of it, okay, and not the decimal part of it. Let's do this. Let's see how we can do this with some geometry. So let's draw a triangle, our favorite. Love triangles, right? Probably sick of seeing triangles, aren't you? And let's do this. Let's say that this angle, I'm going to make it 3x, and I'm going to make this angle 5x, and I'm going to make this one 4x. Okay? And what they're going to ask you to do, we'll make this ABC. What they're going to ask you to do is solve for angle A, angle B, and angle C. What does that mean right there? Does that mean that angle right there is 3 degrees? What do you think? Is anybody going to talk to me at all today? What's going on? Come on. What do you think? Do you think that's 3 degrees and 5 degrees and 4 degrees? Is there any way in the world that that could be that? No, why not? Because what has to happen to all three of these angles? They got to add up to 180 degrees, don't they? So what does this mean? This means 3 times a certain number. This means 5 times that same number. And this means 4 times that same number. Okay, now, if I wanted to find what each of these angles are, what do you think I could do? What's the relationship between this one, and this one? What do all 3 angles have to do? Very good. They have to add up to 180. So this, right, so you're right. And that will tell you that that's the smallest angle, that's the medium angle, and that's the largest angle, right? Okay, so we take 3x plus, what, 4x plus 5x. That's the actual degree of the angle. But the problem is, don't know what x is, do I? So guess what we're going to find? We're going to find x, exactly. So we take those 3 angles, we set them equal to 180 degrees. Why did we pick 180? Because that's what they have to add up to, right? On a triangle, the sum of the angles of a triangle is always 180 degrees. That's why I picked 180. Got it? So now we can actually solve for x. Once we solve for x, we can plug it back in and we can find each of these angles. Do you agree? So this is one of the things they're going to do. It doesn't seem so much like ratios, but that's what we're going to do on this. So let's add these up. 3 and 4 is 7, and 5 is what? 12? Whoops, got ahead of myself. 12x equals 180. Divide both sides by 12, and what's x equal to? Whatever that is, right? And it's 15. I did the math in the other class, so it's 15. So x is 15. But does that tell you what angle A is? Well, it helps. So how do we find angle A? 3 times 15, right? So it's 3 times 15, which is 45 degrees. So that angle is 45 degrees. All right, what about this angle right here? This is 4 times x, or 4 times 15. 4 times 15 is, what, 60 degrees. So that angle is 60 degrees. Now, if you wanted to, you could add this 60 and this 45 and find what this is, right? Or, would probably be the best way. Just take 5 times 15. 5 times 15 is 75, and that's 75 degrees. All right? I'm going to give you a worksheet today, and you're going to have to do stuff like that. Now, here's another twist on this problem right here. Sometimes they'll do this. They'll say that this is like 5x, and this is 3x, and this is like, I don't know, 7x. I'm just making these numbers up. What is this 5x? Is that the angle? No, it's the what? It's the side. And this 3x is this side, and 7x is this side. Now, could I solve for the sides right now? I could add them up, but my problem is what? Don't know what they add up to be. Exactly. I don't know what they add up to be. Okay, but that's what they're going to tell you. Now, what does it mean when all 3 sides are being added up? What word do we use when you add up the sides of any figure, or in this case, a triangle? What word is used when I add up all the sides of a figure? What is it? It's the sum, but it's a good geometry word. Starts with a P. Perimeter, right. It's the perimeter. Right? You've heard that before, haven't you? Yeah. So they will tell you the perimeter. I'm just making a number up. Let's say 78. Okay? So if they tell you the perimeter is 78, then what would you do with these numbers right here? Add them up. Okay, so you add them up, so it's 5x plus 7x plus 3x, and that's going to equal what? 78. And you can, I'll let you do the math. I'm not going to do the rest of this. You could solve for x, just like we did up here, plug them back in, and find the lengths of all 3 sides. Okay? That's going to be some of the problems on your worksheet. Oh, there's one more I forgot. This isn't in the book. I just made this one up. What if we counted up, how many people? 1, 2, 3, 4, 5, 6, 7, 8, 10, That's close enough. Well, let's say there's 9. There's actually 10 girls in here, but let's say there's 9 girls in here. So there's 9 girls in here, and there's, I think, 3 boys, right? 4 boys. We'll say 3 just to make the numbers easy. Is that all right? So we'll say 3 boys. All right. So if I wanted to find the ratio or the, yeah, I guess that's what they're going to say. What is the ratio of, let's say, the boys to the girls in this class? So the ratio means, actually, let's do this. I'll write it out in words. The boys to the girls. I got ahead of myself a little bit. So if I wanted to find the ratio of the boys to the girls, how am I going to write that as a fraction? Boys over what? Girls, right? Okay. So let's put the numbers in. How many boys are there? There's 3. How many girls are there? There's 9. So we always reduce. What does this reduce to? 1 to 3, right? So if I asked you what the ratio of boys to girls was in this class when there's 9 boys or 9 girls and 3 boys, it would be 1 to 3. Now, does that mean there's only 1 boy and 3 girls in here? No, it means what? That's right. For every 1 boy, there are what? 3 girls. Okay? So for boys, that's usually not a bad thing, is it? I don't know. Depends who the boys are, depends who the girls are, I guess, right? So it's 1 boy to 3 girls. And that's your ratio, right? Doesn't necessarily mean there's only 1 boy and 3 girls. What if we said this? What if I said, what if they told you the ratio? The ratio of boys to girls was, I'll make some weird number, it was 5 to 7. Okay? And what if I told you that there were, the number of boys was 30, okay, and you had to find the number of girls, okay? Well, let's see. We've got, what is the ratio? The ratio is 5 to 7, isn't it? Okay, and that's boys to girls. So that ratio should equal what? 30 to, we don't know, right? We don't know how many girls. We'll put G for girls. Okay, is that all right? You put X if you want to, doesn't matter. I'll put G for girls. And now you should be able to figure out how many girls there are. Look, 5 times what is 30? 5 times 6. So what's this going to be? 7 times 6, which is what? 42. So how many girls are in that class or that group of people? 42 of them. You with me on that? So that's, there's going to be some word problems on there that you're going to have to do that. Let me show you another quick little thing. It's called cross multiplication. Do you remember doing cross multiplication? Watch this. If I had 12 over 3, what's 12 over 3 equal to? 4 over 1, isn't it? Watch this. There's a quick little way to see if that's really right or not. I mean, you know 12 divided by 3 is 4, so that's easy. But watch this. What if we did this? This is called cross multiplication, where we multiply diagonally, and then we set them equal to each other. So what is that? That's 12 times 1. That should equal what? 3 times 4. So that's 12, and that equals 12, so that works, doesn't it? So guess what? Those fractions are equal to each other. What if we had something like this, though? What if we had something real weird, like 6 over x equals 21 over 31.5? Now, I can't just look at that and tell what x is. On that other one, that boy-girl problem, I could tell pretty easy, couldn't I? On this one, I'm not really sure. 6 times what's 21? I don't know. All right, but what can you do? We just learned something. Yeah, we can cross multiply. So let's do that. So we can cross multiply and watch what we get. I always like to do the x first. If x is here, I'll do this first. So x times 21, which is 21x. And then 6 times 31.5. I don't know what that is. I'll put that into a calculator in a second. Now, let's get x by itself before we start putting stuff into a calculator. How do I get rid of that 21? No, not subtract. It's being multiplied. So we divide. And we divide this by 21. Cancels out. X equals. What do I do with this? Yeah, put it into a calculator and see what we get. So it's 6 times 31.5, right? And that's 189. And then what do we do with that 189? Divide it by 21, and that gives you 9. So x is 9. All right? So that wasn't quite as easy just to look at and figure out in our head, was it? But we use that cross multiplication to figure that out. So there's several styles of problems that you're going to do on this worksheet. We've covered every one of them. All right. So let me give you the worksheet. It's a 7-1, 7-1, and you're only doing one side of it. I only gave you one side, but because there's quite a few problems on there. So have that finished for tomorrow.